Hi friends, hope you guys are doing well. In today's our section, we are going to discuss about abstract data types, advantages of abstract data type, concepts of data structures, advantages of data structures, overview of data structures, and also the implementation of data structures in our daily life and also in our programming language. Before going to that, I am going to introduce myself, Maram Pranit. I am from JNTU College of Engineering. So let's get started. What is abstract data type? Abstract data type is a data type for object whose behavior is defined by a set of values and a set of operations. And the definition of ADT is only mentions what operations are to be performed, but not how these operations will be implemented. And it does not specify how data will be organized in memory and what algorithms will be used for implementing the operations. It is called abstract because it gives an implementation independent view. The process of providing only the essentials and hiding the details is known as abstraction. This point is very most important in today's abstract data types class. And let us see the flowchart of the abstract data type. In this flowchart, we can see that the application program is getting into the topic that abstract data type. In the abstract data types, there will be the data structures. In data structures, there will be the arrays, linked list, and some other. Let us know the advantages of abstract data types. First advantage. Abstract data types have some advantages over concrete ones when it comes to software development. They are independent. Since the implementation details are not visible, the rest of the program is independent of ADT. We can modify the ADT implementation without affecting the entire code. The second most point is modularity. The program is less dependent on the implementation of abstract data types. In other words, it is easier to spot bugs that belongs to the ADT or the rest of the program and treat them separately. And next one is interchangeability of parts with abstract data types. Each part of the program can use the most efficient implementation that suits its necessities. Now let's getting into our basic topic, data structures. Before going to data structures, I am going to say the basic definition of data structure, which is very much important in our today's class. What is data structure? Data structures is a way of organizing large amount of data more efficiently in common computer memory, so that any operation on data can be done easily and quickly. Data structure defines a logical and mathematical model of particular organization of data. In this, we have data structures is divided into two types, basically primitive data structures and non-primitive data structures, and they are subdivided into several types. Let us discuss it later. So now let us learn about what is data structures. A data structure is a storage that is used to store and organize the data. It is the way of arranging data on computers so that it can be accessed and updated efficiently. So we know the basic example of data structures are arrays. Arrays are basically these types. There we are going to arrange the data in the particular location, and they can be accessed and also can be updated. How they can be accessed? They can be accessed by the index. As basically we know the index are start from 0, 1 and that goes on up to the size. Okay, next point of data structures are data structure is not only used for organizing the data, it is also used for processing, retrieving, and storing data. Now let us learn about the classification of data structures. The classification of data structures are given by below. In the before of linear data structures and non-linear data structures, there will be the primitive and non-primitive data structures. Under the primitive data structures, there will be the integers, float, character, pointer. These are the primitive ones. They are the basic ones. In non-primitive structures, these linear and non-linear will be arrays. In the linear ones, we are going to see static data and the dynamic data. What is static data? Static data means it is the continuous data in which the elements are arranged in a continuous order, and we can gain the element, or we can search the element very easily. That can be implemented by array. In the dynamic data, stacks and queues and linked lists are also available. Non-linear data structures, trees and graphs are there. Let us see the overview of data structures. Following terms are the fundamental terms of data structures. Now let us see what they are. Interface. Each data structure has an interface. Interface represents the set of operations that a data structure supports. An interface only provides the list of supported operations, type of parameters they can accept, and return type of these operations. Let us see the other point. Implementation. Implementation also plays a very important role in the data structures. The implementation provides the internal and representation of data structure. Implementation also provides the definition of the algorithms used in the operations of the data structure. Now let us see the characteristics of data structures. What are the characteristics? Some of the characteristics we are going to display, or we are going to explain now. Correctness. Data structure implementation should implement its interface correctly, otherwise it gets some mathematically or syntactically error. Time complexity is the other most important point to discuss. Running time or the execution time of the operations of the data structures must be as small as possible. You know, the computer takes some more time to take output in several cases. We need to reduce that time and make the proper time to execute the program. In hacker rank, we will see that time complexity is more important. That some of the programs may only recognize the algorithm which can take the better efficient program only. Now let us see the other most characteristic of the data structure. Space complexity. You know, the algorithm we are writing, that should occupy only or up to some amount of data, not much more than the beyond more data. If that happens, the program will not be run or will not be executed. Output will provide some garbage values. So we need this space complexity. Memory use of data structures operations should be a little as possible. Now the need of a data structure. As applications are getting complex and data rich, there are three common problems that applications face nowadays. Now let us see the problems which are facing nowadays. Data search. Let us see what is data search. Consider an inventory of 1 million. 1 million means we already know it is 10 power 6 items of store. If the application is to search an item, it has to search an item in 1 million only. Every time slowing down the search. As we know, the number of elements are increases, the searching capacity also increases, then time complexity of the also increases. So we should reduce this time complexity by implementing better methods in it. Items vary time. Okay. As the data grows, search will become slower. Processor speed, also very important point in our today's session. Processor speed all through being very high falls limited if the data grows to billion records. Now let us see the another most important, that is the multiple requests. As thousands of users can search data simultaneously on the web server, even the fast server fails while searching the data. Now let us see the implementation of data structures, how data structures can be implemented and in which these are going to implement. Data structures is implemented using arrays, stacks, queues, trees and graphs. We know that arrays, stacks, queues are the linear data structures. Linear data structures means it goes in a systematic order. But trees and graphs are not in the systematic order. There will be the hierarchy to attain them. Okay, let's see the other point. So let us learn what is an array and use of array, how it is going to be used, and we are going to see some algorithm based on array on finding an element. Let's see. An array is a collection of items stored at contiguous memory locations. The idea is to store multiple times of same data together. That is called array. It is very simple to understand. Now let us see the other point. This makes it easier to calculate the position. How can we calculate the position? We can calculate the position by using the indexing. In the before I told about the indexing. Indexing starts from 0 and 2 so on. How much the size of the array is. And by simply adding an offset of the base value, so we can add the values also, but the memory location is fixed in this array. Now let us see the other point. There are several operations on the array like searching of element, insertion of an element, delete an element using index location. By the index location only we can delete any element we need. Algorithm for searching an element. Let's see the algorithm for searching an element in an array, not in linked list or stacks or queues. Now let's see. First, input array size and elements from the user. Store it some variables, say size and array. It is very important point. First we should initialize the input array. That should be initialized by any data type. That can be int, character or any other. First we should initialize the data structure. That we should initialize the size of the array up to where we can expand that array. Store it some variable. So let us say everything should be stored in some variable, right? So that can be stored in a ARR variable. And the input number to search in an array from the user is variable say search. Okay, let's go to another point. Define a flag, initialize it to 0. This is what I am saying. You can write flag or temp. Temp means temporary variable that can point to or initialize it to the value 0. So it can start from 0 and that goes to the exact position where your element is. If it founds your element, then the searching is completed, right? And it returns the value, the position where we search. So let's go to another point. Run loop for 0 to size. That is what I am saying now. In an array. Inside the loop, check for the element equals to the searched element. If it is equal, then we are going to print the index of the element. That is very simple. If the element is found, increment the flag to 1 and terminate the loop. Outside the loop of flag 1, element is found, otherwise the element is not found. Now let's see the array. the array size we initialized is up to 6. 6 means up to 5. That means we are going to start with 0 now. So it takes the 6 values. Now let us include the values, that is number 2, 4, 10, 5, 15 and 3. These are the array elements. The array indexing are below 0, 1, 2, 3, 4, 5 as you know. Now let us go to now let us assume we are going to search the element 5. We already know the 5 is in the index 3. But we are going to do some process now. Let's do it. Now we have the arrow in the first indexing. First indexing means we are on the first index of the array. First index of the array. When it is flag is not found, that the element is not equal to 5 now. In the first indexing we have 2 as the element, but we need the 5. When the element strikes to 5, then flag will be incremented. When the flag increments, then we are going to print the index of that particular element. Now let's see on that. In the second indexing place also we have no element, that is 5. In third place we have none. In the fifth place we are striking the element that we found. We found the element in the index of third position, that the element is 5. Now the flag will get incremented to 1. So here we see that flag is incremented to 1. Now the element is. Thank you for watching.